Okay, everybody, this is going to be a short video for lesson 5 on using the second derivative test to determine inflection points. Here, like yesterday, we're going to do the same process. However, the taking of the derivative is harder. It's a more complicated derivative because there's a product involved. There is only one example here, and I already have it worked through. If you notice, the first little message to you in this lesson says, try it before you go to the video or the key. Like, just give it a try, and make sure you do a good job on your cleanup of the derivative. I'll give you a hint also, just to help myself. After I finish the derivative and I clean it up, I just go online to the derivative calculator, and I ensure that my cleanup looks like their end result and that I have it as simplified as possible. And the benefit of this is just to give me confidence, because honestly, if you do the first derivative wrong or you don't clean it up right, you're going to have a heck of a time trying to do the second derivative. And if it's wrong, the whole thing's going to be wrong. So I do verify my steps as I go along using that derivative calculator. So if you haven't done so already, please pause the video, go to the lesson, and give it a try. Take the first derivative using the product rule and try to clean up that algebra. Remember that when you have a product rule with a chain, so the derivative does present a challenge. I highlighted here in my cleanup, don't distribute to clean this up, factor out that common term. It's going to be common because in the first term, it's the binomial from the derivative of the second function, and in the added term, it's the actual second function. So they're going to have that binomial in common. Don't distribute it, factor it out, and then you can clean up. Okay, so pause here if you haven't done that already, so you can give yourself a turn. Use the derivative calculator after you're finished the work to see if you're right. Find your critical values, do your test points, find your max and mins, if there are any. Then do the second derivative, same process. It's complicated. Be careful with your signs, little things. Check it in the derivative calculator. If you don't have the derivative right, doing all the rest of the work is not going to help you, okay? And then get your critical values. For inflection points, do your test points, and you'll get all the good information. Then you could check the whole thing on GeoGebra. All right, so we're pausing and doing that. Otherwise, at this point, I'm just going to go through quickly what ended up happening. I used the product rule with the chain, cleaned it up, had that binomial to be distributed out, distributed it, set equal to 0, test points between, beyond, remember that, before, between, beyond, and then testing those points. I'm evaluating if really, notice I didn't even find out what the value is because it's irrelevant to me. What's important here? Is the graph increasing or decreasing? How do I tell that? By evaluating the first derivative if it's positive, negative, or 0. So I'm looking at either side of those 0 points to see if I have a positive or a negative. So the actual value doesn't matter. You'll see down here in pink, f prime of 0, f prime of 2, f prime of 5, irrelevant to me. What they are, just whether they're positive or negative. Again, you got to take your time. You got to be careful with your signs. You mess up your signs, you have the wrong result. Okay? There's a relative max at 1. How do I know that? Because I'm increasing before 1, and between 1 and 4 is decreasing. So 1 is a maximum point. I plug into the original equation to figure out what the coordinate of that maximum point is. When I'm finished with that, I'm going to take care of the second derivative. All my algebra is here for you to check, but once you do it and practice it, you're going to see how it works. I factored out twice here, just so you know. I factored out the GCF of the binomial 4 minus x, And then after I started cleaning up, I had a factor of 12 in here. It just made my solving easier. You would still get 4 if you solve 12x minus 24, so that step is not required. Just makes it easier to solve when you're as simplified as possible. Okay, again, I have my, I set equal to 0, get my critical values. I have 2 and 4, so now I'm doing before 2, between 2 and 4, and beyond 4. Okay, there's my test points in blue this time. I'm checking if they're positive or negative. And I'm noting that the graph is concave down when it is negative, before and beyond. And then concave up between 2 and 4. Making x is 2 and x equals 4 places where inflection points occur. I sub into the original to find those points of inflection. And then, as a final reward for all my hard work, I go to GeoGebra. As a matter of fact, I'm just going to open it for you. I go to GeoGebra, I put in my original function, I look at the graph, I can put in the extremum value for the function. I get 127, which is the point I had algebraically, and I get the 2 points of inflection at 4,0 and at 216. Now, of course, I know that you could do this on the calculator, but your work would never match that value. Your work would never match that value. So you're going to need to, you can use the calculator to check your work. All right? Your assignment is, besides this problem, there's a homework with 2 more problems for you to work on. Okay? Hope this goes well. And remember, we're available on chat and email for any help or extra help you might need. Have a good day.